Hello, good evening everyone. Today I'll be walking you through my demo of creating an end-to-end GenAI application using some principles of LLM ops. This is part of my submission for the assignment LLM ops for generative AI. So now let's look at the problem which I'll be trying to solve. The first thing I'm going to do is I'll be creating a GPT-like chatbot to allow users to write code in Python as well as in Terraform. So for this, let's look at how our agent will be. So firstly, we need a UI. UI will be very much GPT-like, so it ends up looking something like this. So you have your front end where I have my main HTML file. So since it's a simple UI, I didn't want to complicate it. I just wanted to show the principle of deploying an GenAI application using the ops principle. So it's just a single page application that allows you to chat through a backend. This is your main front end file, which generates something like this. And then in the backend, let's look at our agent. So we have a code assistant agent where we initialize a memory buffer so that we can keep track of the conversation about the messages that's coming in and messages that are going out. We initialize a GPT-4, like a LLM using GPT-4 Mini. We have two tools, one for generating code, another for modifying the code. Using these values, we then initialize an agent, passing it the tools, the LLMs which we are using, and the memory for the chat. Then we just define our prompt. We prompt engineer our two functions so that when we say generate code, we have a specific prompt template. When we say modify code, we have a specific prompt template. And then depending on our input, we decide which prompt template to use. So this is our backend. You will also need an .env file with an OpenAI key like this to allow you to connect to OpenAI. And after that, what we'll be using is we'll have two Docker containers. One Docker container for your backend, the other Docker container for your front end. And then we will use Docker Compose to make sure that both the containers are in the same networking environment and can talk to each other. And you have a single command to run to have both of them up. The reason for doing so is this is not just even though the front end is pretty small, it is to represent the idea of how you can have two separate, like have front end and back end completely separate and have them running. Once we have that we have the Docker file for back end and front end, and then you have the Docker Compose file. Here I'm saying that the services are first services is the front end service. The context, it will look for the front end folder. We do a port mapping of, we map the local host, uh, the port 3000 of our local host to the port 80 of the port 80 of the front end port, and we specify that the front end port depends on our backend service. We then define our backend service, the context, the port mapping, and some environment. You can even pass the OpenAI key over here for it to work. Now, one thing you need to know is what will happen is we'll be using NGIX for our backend, and for our front end, we'll also be using it. We'll be using Flask for our backend. So this is what our Flask looks like. So we have one method which is respond. We will get the message from user based on what they want to do with the like particular prompt or whatsoever. And we use that prompt, we'll pass it to our agent and we return back our response. If you look at the Docker file, it's a pretty straightforward Python file. It's a Python-based Docker image, and we just expose the port 5500. My laptop had some issues on running the port 5000, so just it's another port which I just chose to run it on. And similarly, in the front end, we have an ngix image where we'll copy the index.html into current working directory, which will be like so by default, this image has the nginx service running and it renders the index.html file. So we are just copying it over there. By over there, I mean in this directory. And we expose it on port 8080. And if you remember in the Docker Compose, we do a port mapping of 80 of localhost of 3000 to 80. So once you have everything up, we'll do a Docker Compose up to have both the images running. You can do build Docker Compose up build if you want to force Docker to rebuild all the images, all the containers. Just gonna do build. Okay, so now my front end and back end are running. So this is what my front end looks like. Now let's converse with our LLM. Converse with our agent, sorry. So hello, can you generate a Python code for bubble sort? Now this takes about 10 seconds. We can monitor the logs over here. Okay, we got the backend 200. We should, okay, here is the, this is how our Python code would be. Now it is also capable of generating code in Terraform. If I can you generate the Terraform code for the creating an Azure VM? That's the part. We should create another 200. Yes, here you see. So you have the Terraform code where it has the virtual machine, the size, the storage, and whatsoever. Now let's modify. Can you modify the Terraform code to include creation of a resource group? Here you see it creates the resource group, the virtual network. Right now we are using a lower level model due to my quota limits, but you get the idea of how you can use like a better model to get even better predictions, and how we can use the same principles to build even more and more complex applications using GenAI tools. That's it for this presentation from my side.